All right. Everybody online can hear me? See my screen?
Sí, señor.
All right. So homework for today should have been fairly easy. It was write the extractors for our code thing, and that was for unparse, right? Um, Parse is really the important piece that we want to be able to. Actually, it was for. No, it actually was for parse expression. So we do need to write them. And then the other thing was to come up with a name for our programming language. Anybody have a good suggestion before we get
Something to do with Clancy.
It's not the first time that the language has been named after some student in the class, but we have like a legitimate thing, or is it just called Clancy? Clancy would be easier to spell than code spelled this way. What'd you come up with, Brocker? The language is called Shut Up. That's it? Never creative. Anybody have anything creative, good they came up with?
Scheme nightmares.
Who what? Something nightmares?
Scheme nightmares.
Nightmares. So far, none of those are better than what we have here. All right, well, let's stick with code then. So let's write our extractors for our I think somebody might have tried to say something, but it didn't come through. All right, so for code extractors, we need to be able to, these are the guys that look kind of like our, these guys up here. In fact, we'll just steal one so we have our baseline for it, and then we'll insert it into our parse. All right, so we want to be able to go from a, for code, we're going to have a get value. So get value to what? Get value expression to value, something like that. And this guy will take in a code expression, and he'll boil down to the catter of that code expression. Okay, so that's effectively what we did right here. And then we'll actually call upon that one in here. So we'll call the get value expression to value. Next one is going to be a func expression. So func expression. And these guys need two pieces of information, right? We need the parameter, which will soon become parameters. And this guy's going to take the code expression, and he's going to boil down to, I think it's probably just to there. rather than a what expression? Actually, yeah, you would probably take it a func expression. Even the first one. This would probably be a get expression or get val expression. And this would be a func expression. All right, so then we can say that guy like that. And then the next one would be what, get body. Func expression to body. Something in that ballpark. All right, so that should give us the body. Like that. And then the last one is our run expression. And what did we call the parts of our run expression? Get the function, func, run expression to func. Oh, I need to update these guys up here. This should be func expression. All right, that guy should be good. And then the next one is what, get parameter. Get input, run expression to, what do you think? Input parameter. This guy, so to hold on. I didn't update this guy here. This is the catter of this guy. And this guy was the CATDR. So that's the function. That's the parameter. Okay, so those should be cleaner ways of working with our language. Run this and make sure it still gives us what it's supposed to give us. CADDDR. Set to the function after the open parentheses. Received. Get value A. Why is that a problem? What didn't I do? We left this and it was running before, right? Okay, so this was 3Ds, wasn't it? The received list, get value A. So that would have been this part right. This is a run expression. The C, the car is that, the catter is that, CADD is that, CADDD is that. Oh, no, I don't need the parenthesis before it. That's where the error is. There we go. I had that guy surrounded and he was trying to call a function named that. Okay, yeah, so now they inverse each other. Great. All right, so that was for our parse expression. Unparse expression is really just a test against the making sure our parse expression works. So it's not something we'll necessarily work with. All right, so now we have the ability to write code this way. We want to run this function. It gets a single input. It does something else with, here's our input, right? So that's what we want to be able to do. Now we've parsed it into a lambda calculus expression. So now we're at something that could potentially run. So then what comes next? So I've converted between our syntax and our internal syntax. And now I have our code that we're supposed to run. Now I actually have to write the interpreter, right? So right now we have something that is a collection. We name them expressions, EXPs. So we're going to have something that we have to apply an expression to. So we're going to start off. We already have our environment stuff. I'm trying to think where I should put this. I'll put it just below the parse stuff. So we're going to define apply expression. And this guy is going to be a lambda. Now remember, we're dealing with what's called environment passing interpreters here, which means that we're going to pass in a lambda calculus expression that we're currently executing, along with the environment in which we're executing it. Does that make sense? We have two parameters that come into this guy. So we have a lambda calculus expression, and we have an environment. So we'll start off with our cond. So now we have three different things that we could run into when we're dealing with our lambda calculus expression, right? We can be dealing with we have predicates for this. We can be dealing with a var expression. That's one of our things, right? So if I'm looking at a var expression, lambda calculus expression, what do I do with var expressions? What's the purpose of a var expression? Now we're actually executing our code, right? So if you're in Java and you run into a line that says a plus 3, a would be our example of our var expression, right? What do we do with that var expression? Get its value. And how do we get its value in our current code? What do we have to get the value from our environment? We have a thing called apply env, passing it the variable name. So we need to extract the name of the variable from our lambda calculus expression and call apply env on that, passing also in the environment. So we have our extractors. So we have our var expression to name. That's the actual variable name we're looking up, right? We're going to use our extractor here. So that's going to get us our variable name. What do we do with that variable name? We call apply env, passing it our variable name and passing it the environment in which we want to look up that variable name. That make sense? So we could test this one thing real quick, right? We can say, okay, well, let's what this call apply expression, passing it our var exp constructor, and we'll pass it a. And then we also need to pass it our environment. And didn't I give myself a test environment to work with here somewhere? There we go. I zigged what I should have zagged. All right, so we'll define our environment to be an environment that has CDE 1, 2, 3 in it. So A is not going to be a thing anymore, so we have to have D. All right, so we're gonna apply an expression. What expression? Our var expression with the D inside of the environment that we created here. So our type is going to be a var expression. So that's the only type we support right now. So what are we going to do? We're going to call apply env on. We'll extract our variable name from that var expression and apply it inside of that. So we expect to get a 2 out of this for our var expression. And there's our 2. So what do we do when we run into a var expression? We resolve the variable. We look it up in our environment. All right, make sense? All right, so that's the first part of our apply expression. If it's not a var expression, it might be a lambda expression, right? Get up to our predicates so I don't misspell it. So if it's a lambda expression, lambda calculus expression, what do we do with lambda expressions? What do lambda expressions tell us to do? What happens as part of a lambda expression? Lambda expressions are functions, right? Okay, and we call functions using an app expression, our last type, but when we're just executing a lambda expression, what do we intend to do? Okay, so run the body on what parameter? So we want to execute the body. So we want to apply expression on the body. And presumably, apply expression on the body is going to be using the parameter that was passed into the lambda. Where does that parameter actually get bound? So let's say we had a lambda that takes in an A and boils down to A. So it's the var expression in there. Does the binding of A to whatever its value is, does that happen in the lambda expression, or does that happen in our app expression? App expression. So all a lambda expression does is execute the body of the function in the current environment. And how do we execute a lambda calculus expression? Call apply expression. So if this is what we're dealing with, what will we do? We'll call apply expression on the body of this lambda. We'll go get our this guy. Using the current environment that we have. Right? Because that's what when we have a function, that's what we do. We call the body of the function. That's what the function does. Okay? Now, we'll go ahead and, since we're going to be adding some stuff to it, we'll give ourselves like a global else at the end that just returns false or something because, you know, hey, you gave me something I didn't know what to do with. So we'll go ahead and keep with our predicates here. So if we're looking at an app expression, what do we do with an app expression? App expression has two things. It has the operator, which is presumably a lambda. And what's the operand? What do we do as a result of calling an app expression? We need to create a binding. Okay, and what are we binding? We're binding what to what? Let me just show you, so I'll just write it here. So let's say I have a Lambda A 5. So that's like an example of an app expression that I just wrote there. So that thing that I'm looking at right now would fire true for our predicate, or generally speaking would fire true. I forgot the words we might have used, but that's an app expression in Scheme. So that guy would fire true for being an app expression. So what do we need to do? We need to first bind what to what. So we need to add to our environment. We need to extend our environment with a new variable, A, being bound to the value of 5. All right, then what do we use that environment to do? Well, once we have this guy bound to this guy, now I'm prepared to execute the body of this guy. And how do we execute the body of the lambda? Call apply expression on the body. All right. So what we're going to do is we're actually going to do this as a with a let here, because I think that we're going to start using lets more and more, and I think this will be beneficial for us. So if I'm looking at a app expression, then I need a couple of pieces of information here. I want the lambda part of this. That's the operator. And then I also want the value I'm binding part of this, which is the operand, right? Or whatever we call them. We call them raiders and rands. We called it lambda expression, and we called it parameter input. That's what we call those guys. So I want to get the lambda expression from this guy. So my result here is I'm going to create a let. So let allows me to create a local environment. Okay. And in this local environment, we have a list of name value pairs. That's what goes in here. So I'm going to call this guy my lambda expression, and he's going to be equal to app expression to lambda expression, lambda calculus expression. So I'm going to have a local variable here called lambda expression. In fact, actually, let's call it the lambda. Okay. Now I'm also going to have another name value pair that's going to be the value that I'm binding. So the well, I'll do it in two separate passes. So I'll go ahead and say that the parameter value is going to be my app expression. Parameter input. Of my lambda calculus expression. I know my lambda calculus expression right now is a app expression. I wouldn't be in this part of the cond if it wasn't. Okay. Now, ultimately, what I'm going to be doing is I'm going to be binding this value, the parameter value, to the actual variable portion of my lambda, right? But I don't actually have the variable portion right now. And with a let, I'm going to show you what I want to do, and then tell you that I can't do this. I really want the lambda param name. I want that piece. And how do we get that piece? Well, we use our extractor for lambda expressions. Lambda expression parameter name. This is how we get at that piece. And who has that? It's going to be my lambda. That's the one who actually has that piece for me. The problem is that when you use a let, there's three different kinds of lets. You've probably seen them used in the book. I don't know that we've done them much in class. Have we worked with these at all? You kind of know that they exist, but that's kind of the end, right? So we have three different levels. So what is a let? The purpose of a let is to create a local environment, to create local variables, right? So we're basically giving ourselves some local variables that we can then use for the logic portion, the body of this let, to make it a little bit cleaner for us. There's three different kinds of lets. We have a normal let, we have a let star, and we have a let rec. Now the problem with a normal let is, and actually I can probably just do it down here if it'll let me pull it off. So if I say, if I create a let, and I say A5, B6, C plus AB. Actually, will it let me do pluses in there? I don't, it might not. I'll just do CB, that'll work fine. Just go like that. Keep it simpler. So if I do a normal let, and then the body of it, I say plus AB, something like that. What I'm saying is define two variables. The first variable is A is equal to 5. The second variable is B is equal to A. So A and B should both be 5, and I want the sum to be 10, right? The issue here is that lets do not allow me to do this. Hopefully it gives me the correct error message and doesn't yell about something up there. Yeah, so A, this variable is not defined. So a normal let does not allow me to define other values in terms of values previously defined in the let. Like what I'm trying to do up here. I'm trying to define lambda param name in terms of the lambda. It doesn't know about the lambda yet. A let star, this guy will let you define variables in terms of previously defined variables inside of the same let. So this guy will allow me to do it, a let star. Make sense? Now a let rec, this guy allows you to make recursive calls, because technically, since functions are values that are legal, nothing keeps me from saying B is a lambda that takes in an X and boils down to plus X1, something like that. And then what I can do in here is I can say B applied to A. So A is 5, B is a function that takes in a single parameter and adds 1 to it. So my parameter would be 5, this would boil down to a 6. I can do that with a let, because none of these are, so B is not defined in terms of A. Does that make sense? These two guys are completely mutually exclusive from each other, these two variable names. A is determined, is bound to 5. B is a function, which that seems kind of weird that, oh, I'm associating a function with a variable name, but it doesn't have any impact on my A, so no harm, no foul with a let. Scheme allows us to have values that are functions. That's what a lambda is. It's an unnamed function. Okay, so we can pull this off with a let, but what we can't do with a let is we can't do something like, steal this. I can't say that. Where my lambda is, takes in an X and it adds X and A together. Where A was previously defined inside the let. Gonna yell at me and say A was not defined. So my lambda here, instead of saying X plus 1, I'm saying X plus A, where I'm relying on the value of A I bound here. A let won't let me accomplish that. A let star would. Well, that's a good question. Why wouldn't you always use let star? The follow-up would be, why wouldn't you always use let rec, which would be the next one I'm going to talk about. The idea is there's somewhere in there there's a performance issue. You know, the more complicated, the more magic tricks it can do, the slower the program will be. Having said that, I don't think your question is a bad one. Let star, I think, is almost always better than let. At least gives you the flexibility to define variables in any order and in terms of each other. Now, what you can't do with a let or a let star. So here, we'll look at a weakness with a let star. So we understand the difference between a let and a let star. Let star lets us define variables in terms of other variables inside of that let. So it kind of lets us do what we want to do up top here. What we can't do with a let star is, let's say we have A is 5, my environment here. And then let's say I'm going to, just so I don't get, I'm going to create a function called factorial. And factorial is going to be a lambda that takes in an x and asks the question if equals x1, boil down to 1, else boil down to times x factorial minus x1. And then I'll call factorial of A as my body. So we saw just a second ago that a let star lets us, well, even a let and let stars allow us to have functions as long as they're not defined in terms of each other. But neither of those allow a function to be defined in terms of itself. In this case, my factorial functions, this variable, which is the value is a lambda, it's defined in terms of itself. Inside of his definition, he calls himself. Let and let stars do not allow that. This function is not defined. When it got to factorial here, it said, since I'm in the middle of defining it right now, it says, I don't know about this dude. That make sense? So if we want to have recursively specified functions, we would use a let rec. That allows me to define functions in terms of themselves. This is a let with recursive support, we could say. Which would then, to follow up on Brocker's question, he would say, well, why wouldn't we just always use let rec? So, like, look, I want to be able to do whatever I want to be able to do whenever I want to be able to do it. So why don't we just always use a let rec? You're not wrong. Yeah, so I mean, you can say we could have a very similar conversation with the difference between equal versus EQ versus EQV versus equal. Equal always works. Doesn't matter what kind of animal you're working with. So why don't you just always use that? Performance, maybe if you cared, type thing, something along those lines. We don't, because we're thinking more about the constructs, but I'm going to use a let star here. We'll attempt when it makes sense to kind of use the right tool. But I'm going to use a let star here. Why am I using a let star? I'm using a let star because my intention is that I want the lambda param name here to be defined in terms of the lambda, which I defined inside the same let. So I'm going to need a let star in order to accomplish that. That make sense? So this let star gives me 3 variables. I have my lambda expression. I have the parameter inside that lambda expression. I have the name of that parameter. And then I have the value that should be associated with that parameter, that should be bound to that parameter from my app expression. Those are the 3 pieces that I need. All right? Because I'm going to be binding that variable. So what variable? I'm going to be binding the parameter value to the lambda parameter name. I want to create a binding for that. How do I create a binding in my current environment with those 2, with that name value pair? Send D and V. Okay, so Actually, why don't we just keep doing it inside the let to keep it even cleaner? So we'll say the new, we'll call it the new ENV is extend ENV with what? We give it the name and the value. So the name is the lambda parameter name. The value is the parameter value. And what's the environment we're extending? That right here, the environment that was passed in, I'm extending that environment. So here's my updated environment now. So I went ahead and I bound this new name value pair in my current environment, extended my current environment with that new name value pair. So now in the body of this let star, I can go ahead and call apply expression on what? I can call it on my lambda. That's the expression I'm applying, right? My actual function. Really, you could probably actually get the body of it here. But we don't have a fancy enough syntax. We don't have a fancy enough syntax yet to really have a the only thing we could do is resolve a var expression at that point, which is what we're supporting. Somebody have a question? So for now, we'll go ahead and just have it execute the lambda, assuming that there's already a binding for it. So we'll call apply expression on the lambda in our newly extended environment. All right, that makes some sense? Oh yeah, but you're right. So it gives you local variables. So it kind of gives us a nice little, you know, encapsulated area where we can create 3 or 4 variables that we're going to use so that we, you know, have maybe a little bit cleaner final call. But yeah, what he's saying is we could have used all these extractors in just one scary line here that would have been pretty messy, but would have ultimately said the same thing, right? All right, so let's back up here. So now I have, here's the function I want to run. I want to run a function that takes in a single parameter and it looks up that parameter with my get value of C. Now, I go ahead and my unparse just proved that that worked. So I need to parse that expression, right? And actually, maybe what we do is we maybe have a something called run program. Define, we'll call this run program. This is a lambda that takes in a code source. And what it will do is it'll call apply expression. Actually, we should probably pass it an environment too. It'll call apply expression on the parse expression version of code source. I need to turn it into my lambda calculus expression format, along with the environment in which I'm running it. So here's my code, here's my environment. I'll go ahead and call run program on my code and my environment. And what does run program do? It goes ahead and it parses that code into Lambda calculus and calls apply expression with the environment I passed in. And what should this guy ultimately do? Well, here's a function that takes one parameter and just boils down to whatever that is. And I'm passing it in with, so this is ultimately, this is my app expression, right? My run. So I'm going to get the value of C. So the value of C here is a 1. I'm going to bind A. Excuse me. I'm going to bind A to my 1. So A will be equal to 1, which is it's equal to the value of C. And then my function will boil down to whatever the value of A is, which is going to be a 1. Apply. Where were you on that one, Clancy?
You just, yeah, I was going to say you got 2 P's, but you just kept talking, so I didn't want to interrupt.
All right, so actually, this is interesting. So my output was var expression C. One of our extractors or something I don't think is working the way it's supposed to work. Let me look at parse expression on this and make sure it. All right, so we have an app expression. The first element of the app expression is this lambda that takes in a parameter and just boils down to whatever that is. The second element of that app expression is my var expression. Oh, this is the problem. The parameter value here, we're presuming is a literal. Our language doesn't even support literals yet. This guy, as of right now, he is a expression. And what do we do with expressions? We call apply expression on them. So I have to call apply expression on this particular expression along with the current environment. So the value that I'm ultimately going to bind to my new parameter is going to be whatever value I come up with when I call apply expression on the app parameter input, which is one of my 3 lambda calculus expressions. We know it's going to be a var expression in this case. That's the only thing that would make sense. We don't support lit expressions. That's like, we don't support just saying 5 or 7. We require an environment to do the lookup. So I need to call apply expression on this var expression in the current environment to go and look up what that literal value is. I get the 1 in that case. Right here, I actually bind that 1 to the value. The reason we're getting this right here is because the value that I connected to A was var expression C. I never actually applied the expression on that. So if I apply expression of var expression C, I get a 1. So that's why I'm applying expression here now. What expression am I applying? The one associated with my parameter input in my app expression. Where am I applying it? I'm applying it in the current environment because I can't extend my environment until I have that answer that I then am going to use to extend my new environment with my new parameter name from the lambda and the value I just looked up. So there's our 1 there. And if instead of C, we said E here, now we're going to bind A to the value 3, so we get a 3 out of this. So on and so forth. All right, makes some sense? All right, so this is version 1 of apply expression. Not too bad. Things got maybe a little hairy in here because we were just introduced to let expressions. But now that you see the 4 parameters that or there's 4 variables we set up here, does it make sense why we needed each of those? Or why it was beneficial for us to kind of put those in separate variables so we could then use them? I'm going to take this last piece out so it doesn't muddy our water. Because the last thing we're doing here is running our program. Okay, so at this point, our language is fairly gimpy, right? We can't do very much with it. All we can do is look up variables, have functions whose body can only look up variables, or call other functions or something. We can't really accomplish much. So if we take this one step further, it might be nice if we had the ability to have literals, right? A literal expression. What is a literal expression? What's the difference between a literal expression and a var expression? So a literal would be like a 5 or a 7 or an 8, something like that. A var expression like an A, a B, a C. What's the difference between the two of those? Yeah, it's just a value. We don't have to go and look it up in an environment. It just boils down to it, right? All right, so we need to go and add builders for our, we probably call it a lit expression, something like that. So we'll make another pass where we have our version 1 of our programming language. Extremely impressive, okay? And we're starting to see, you know what, things are kind of working. Let's add some features to it. At the very least, we should be able to hard code some numbers in there. Makes some reasonable sense. Okay, so let's go down and get to our grammar constructor. So we're going to add a new constructor. So maybe a lit expression. This is a lambda that will take in a value, and it will boil down to a lit expression of that, whatever that value was. Look reasonable enough? Okay. Now for our extractors, we're going to have a define. I'll put it in the second one right before the var expressions, actually. Lit expression to value will be a lambda that takes in a lit expression and boils down to the catter of that lit expression. So we'll get to the actual value from that guy. The car is lit exp, the catter would be the 5 or the 7, whatever it is. All right, we'll have our predicates for this. Define lit expression to be a lambda that takes a lambda calculus expression and boils down to whether lambda calculus expression to, it'll go a whole lot better if I don't try to spell this because I'm not really having tons and tons of faith on Clancy right now. The thing. We want to know if this guy is a lit expression, right? So that'll return true if it's a lit expression. All right, so now we need to decide how do we handle our syntax for our code lit expressions. So for a variable of our expression, we call that a get value, right? What will we say for a lit expression? Maybe just call it literal. Again, we're doing this as for beginning programmers, so we're not necessarily trying to save keystrokes. We're trying to really be explicit about what things are. We don't go around in normal life talking about things as literals. Right? You kind of know the meaning of it once you hear it, but it's not something we say. What literal am I thinking of? All right, so why don't we, for our syntax, we'll say instead of get value, we'll just call this literal. So extractors, we'll have a define literal exp to value. This will be a lambda literal exp. I'll return the catter of that literal exp. It's the value that's in there. And let's go ahead and add that to our syntax here. So we'll say literal 5, something like that. That's how we'll define a single value 5. So now we'll need to teach parse expression how to work with these literals. So if I'm looking at a literal, what do? We create a lit expression out of the code. That's how we build a lit expression. Okay, so that'll be for parse expression. Now, realistically, I don't think there's much value in updating unparsed expression. Unparsed expression was a proof of concept for undoing what we did, so let's just get rid of it for now, rather than have this antiquated version of it sitting there. All right, because parse expression's needed. Unparsed expression was not required for what we're doing here. All right, so now when we call apply expression, we'll add, we're dealing with a lit expression, lambda calculus expression. What do we do with lit expressions? How do I apply expression on a lit expression? So if I have a lit expression that holds a 5, what do I ultimately want the output to be? 5. How do I get the 5 out of a lit expression? Yeah, I got an extractor for that guy. So here's my lit expression to value. All right, what do I do with that number?
Wouldn't you want to apply it to the environment?
Okay, why do I apply it to the environment? What would happen if I looked up in my environment for a variable whose name was 5? 5's a value, right? Not a symbol. If we apply the environment, we would be looking for a symbol and trying to get its value. So the purpose of apply env is to get the value associated with the symbol. What if I already have a value? Is there anything special to do? If I already have a value, spit it out. I don't need to apply expression on it. It's not an expression. I don't need to look it up in the environment. It's not a variable. It's already a value. I'm done with it. So get me the value of this lambda, of this lit expression, and just boil down to that. So that's what lit expressions ultimately do. Now this should allow me to now have a literal 5 that I can put in my code. So now I can boil, associate A with the value 5 and ultimately boil down to 5. And there's my 5. And actually, I'll go ahead and I'm going to keep our parse expression thing out here. I think it might be good when you're looking at the code for you to see what it parsed into as you're trying to walk through and see what happened. So if I run this, you'll get the final answer. We saw that it worked. That's not what it's called. It's called this. So there, notice we have a lit expression, which is our 5, and that's the operand that's being sent into our app expression. All right, that added some flexibility, right? So now I can, have a function that passes some stuff in, and I don't have to associate it with pre-existing variables. Okay, great. Now, currently, all we can do inside the body of our lambdas is what? Look up a variable. I guess I could boil down to a lit, right? Like I could say, like, okay, well, technically, this function gets a parameter, but I'm going to choose not to use that parameter and just boil down to a 7 for no good reason. I pass the 5 in as a parameter of the function, and what does my function do? It boils down to 7. So there's my 7.
Beautiful.
Go ahead.
I said beautiful.
Yeah. So we still have to take in that parameter, right? Because our lambdas require exactly one parameter. If we were writing this in Java, even though we would say, why would you ever write this in Java? You would say, okay, well, at the very least, this is a function that takes no inputs. If all it's going to do is spit out a 7, I don't need to give it a 5, right? But currently, our language is a bit hampered. So it is what it is. That's fine. So we'll switch this back to a get value. Okay. Now we're back to our 5 for this guy. Okay. So we would probably want to be able to do other things inside of the body of a function. Like when you think about when you're first starting to program, what are some abilities that you are able to do inside of your programming language? Right after you learn variables, but kind of before you start dealing with if statements and loops and things like that, when you start kind of messing around with variables and values, what kind of stuff are you usually messing with?
Basic math, addition, subtraction, multiplication, division.
Yeah, mathy stuff. Kind of almost using the language as like a calculator, right? So actually, for starters, I'm going to do one thing. I'm going to create a new repository. I'm going to call this guy code language. Because it doesn't really matter where I put it. I'll just put it in my Dropbox. I will just do CSC470 fall 2020. I'll create a repository there. And then I'm going to save this as I'll just put this interpreter in there. And just so I know I'm always working off of that one, I'm going to open. Yeah, it's in the right place now. We'll say this is my initial commit. Commit this to master. I'll publish the repository. I'll make sure I set this as public. So here's our repository for our And so moving forward now that our code's going to start getting bigger and bigger, when you submit your homework, submit for me a Git repository so I can easily click on it. Not a .rkt file. .rkt files are weird to open on my phone. But Git repositories are easier, and this is going to get pretty big pretty quick. All right, so set up a Git repository. If you haven't done that before, I think everybody in here probably has, but GitHub Desktop is the tool to use. Find a YouTube video on it. I basically just showed you how to use it. So just watch my video, creating a new repository. The key thing there is that when you create it, make sure you uncheck the keep it private. That way I'll be able to see it. Okay, so I gave you the current state of our code. Now for our homework, do it. Add to our language facilities to do basic math, plus, minus, times, divide. These should be accomplished through a math expression, which requires an operator and two expressions, two lambda calculus expressions to work. So for example, you can say plus var exp a and lit exp 7, something like that, and it would look up the value of a, get the value of 7, add them together, and boil down to the result. You can decide how you want this to look in code. You could just use the normal operators if you want. I think that's pretty easy for most people. I don't think we need to like spell out the word plus or anything like that. I think plus sign, people know what that means. So I guess we were writing the equivalent of this in code. This would be plus, and then this is a get value a, and this is a literal 7. So you will need to add constructors and extractors, as well as update parse expression and apply expression, you might find it handy to create helper functions for actually doing the math to keep the interpreter itself from getting too bloated. Not that doing math is difficult, but you could imagine if you basically embed, if it's a plus, add them together. If it's a minus, subtract it. If it's something else, you just you add a big chunk of code right in the middle of your interpreter instead of just saying do math, passing it the operator, the two resolve the values. Make sense? So that would be my recommendation. You can do it however you want. All right, questions about what I'm asking you to do? It's just going to get more interesting from here now that we're actually into the language. All right, I will see everybody on Tuesday. My event did get rescheduled. Hopefully everybody saw that for next Thursday. So I think we'll probably have to go to our other plan for next Thursday, but the world's out of my control these days. So it is what it is.